This is our second type of conic that we'll encounter. This is section 10.3, and we'll be talking about the ellipse. The formal definition would be the set of points in a plane, the sum of whose distances from two fixed points, the foci, is a constant. And so looking at this picture, you have an ellipse. You have a major axis. The center is on the major axis. There's a minor axis with some vertices here. Main vertices are on the major axis. The foci are inside the ellipse, and they are the same distance from the center. So you have two different kinds, but let's look at some of the important points. In this picture, we have the major axis, and you can see it goes along, and it is, this one is on the x-axis is the major axis when your center is at 0, 0. And so your vertices are A0 and negative A0. The minor axis, you have 0B, 0, negative B. The foci are given the letter C, negative C. All right, so here's the two different equations. X squared over A squared plus Y squared over B squared equals 1. That is the thing if the major axis is along the X, and so it would be this shape. If the major axis is along the Y, you're going to get this shape. And so here's the difference in the equation. Note the difference is the x squared and y squared stay in the same place. The a squared and b squared switch. So in this one, a squared goes under the x squared. In this one, it goes under the y squared. So you can remember, if it's going along the x, that's where your a goes. So let's look at this example. Find the equation of an ellipse with a center at the origin, one focus at 3, 0, and a vertex at negative 4, 0. So in this, we have that A is 4, C is 3. How do we find our B value? Well, in these equations, you are given this. B squared has to equal A squared minus C squared. So we use that, and we plug in the pieces that we know, and we get B squared is 7. So B would be the square root of 7 if we needed the B, not B squared. But when we plug it in to the equation, we have A is 4, so that's A squared is 16, B squared is 7. And we're talking about this one, okay? Because your focus is on the X, and we know that the focus is always on the major axis, so it's going to be this one. So that would be your equation. On this one, you are given the equation, x squared over 25 plus y squared over 9 equals 1, and we need to figure out what are our vertices and major axis, that sort of thing. So A is 5, B is 3. We need our C value. We can use this formula to come up with that. So we have 3 squared equals 5 squared minus C squared. You end up with C is plus or minus 4. So when we start to write in everything, we have the vertices are at 5, 0, negative 5, 0. That's the major. The minor would be 0, 3, 0, negative 3. And the foci would be 4, 0, negative 4, 0. And then you could graph that. All right. Now, you also have to worry about ellipses with the center at h, comma, k. There's a whole nother chart on your page that you might have printed with that information. So x minus h squared plus y minus k squared over b squared equals 1, or the a's and the b's switch. And remember, your a is your bigger number. So if your bigger number's under here, you're going to be parallel to the y-axis. If it's bigger here, you're going to be parallel to the x-axis. And so let's look at this one. Analyze this one. And so the bigger number here is under the y. That means we're going to be parallel to the y-axis. The center is going to be at a +3 and a -1. Remember, they will change sign because you're pulling them out of the parentheses. So the center would be 3, -1. The a squared is 9, which gives you an a value of 3. B squared is 4. That gives you a b value of 2. The foci, and here's the formula, h comma k plus or minus c. So h is 3, and then k is -1 plus or minus c is the square root of 5. And you could find that square root of 5 by using your equation, b squared equals a squared minus c squared. And then the vertices are h comma k plus or minus a. So 3, and then -1 plus or minus, your a value is 3. So you would have 3, 2, and 3, -4 for your vertices. And so that would help you with that. I don't have that picture graphed, but that's the analysis. All right, let's go look at our problem sets and see what we have there. All right, number 1, find the point that is symmetric with respect to the y-axis to the point 3, 6. Well, the point that would be symmetric would still be on the y value of 6, but it would be -3, 6. Blank is the collection of all points in the plane, the sum of whose distance from two fixed points is constant. That's the definition of the ellipse. For an ellipse, the foci lie on a line called the major axis. So remember, the foci are going to be with the major axis. For the ellipse x squared over 4 plus y squared over 25, the vertices are the points. And remember, the bigger number is under y, so we're going to have the vertices be 0. Square root of 25 is 5, so 0, 5, and 0, -5. For the ellipse, what is that one? Oh, it's a little different. For the ellipse x squared over 25 plus y squared over 9, the value of a is, well, remember the bigger number is over here, so there's your a, 5, and the value of b is 3, and the major axis will be the x. If the center of an ellipse is 3, -4, the major axis is parallel to the x-axis, and the distance from the center to the vertices is 5 units. Then the coordinates of the vertices are. So that means it's 5 units either way from 3. So that would be 8, and it would be -2. And then your -4 would still be in both of those. So 5 units either way, 5 plus 3, 3 minus 5. So that's how that would be. All right, analyze this one. X squared over 64 plus y squared over 16 equals 1. Your bigger number is here, so a is 8, b is 4. We use those two and this equation to come up with c. Remember that if you get plus or minus the square root of 48, you need to simplify that. And over here I showed that. You look for the biggest perfect square that divides into 48. That would be 16. So you have square root of 16 times the square root of 3. The square root of 16 is 4. So 4 square roots of 3 is what your c value is. So over here, what are the coordinates of the center? That'd be 0, 0. The vertices will be 8, 0, and -8, 0. Square root of that. Coordinates of the foci, they will also be on the x, and it will be your c value. So 4 square roots of 3, comma 0, -4 square roots of 3, and 0. And over here, we know it's going to be going this direction, and we know what the vertices are, so we should be able to come up with the correct match of the graph. Number 8. Now, what we need to remember is that this number here has to be 1. So before we start analyzing, we're going to divide everything by 400. So 25 over 400 becomes 1 over 16. So x squared over 16 plus y squared over 100 equals 1. Now we can do our work. The bigger number is here, so a is 20, b is 4. We can use those numbers in our equation to come up with square root of 384. That one's not as apparent. You just start looking at your perfect squares and see if something will go into that. And the square root of 64 times the square root of 6 works. So that's 8 square roots of 6 is your C value. So coordinates of the center, 0, 0. Coordinates of the vertices, 0, 20, 0, negative 20. Coordinates of the foci, 0, and then plus or minus 8 square roots of 6. So that's where we got that. And that's going to be, along the y-axis, because remember, here's the bigger number. So it's going to look like this, and that shows up there at 20 and negative 20. So then we should be good there. Number 9, find an equation for the ellipse. Center at 0, 0, focus at negative 12, 0, and vertex at negative 15, 0. So we know that A is 15 and that C is 12. We can figure out B from doing our equation, and we get B squared's 81. That's really all we needed, because we need this part of the equation. They've put the equals 1 over here, so you just have to put x squared over 225. You're squaring 15 over y squared over 81. Square the 9, and that would be that. And we know that the bigger number is under the x, so it's going to be going this way, so the x-axis is your major axis. Number 10, same thing, find the equation. The focus this time is 0, negative 12, vertex is 0, negative 15. So A is 15, but it's going to go under here. C is 12, figure out your B. B squared is 81. So we have x squared over 81 plus y squared over 225. And then we know that's going along the y-axis, and we should be up here at about 15. And then we should be 9 this way. So I think we should figure those out. Number 11, they've given you a picture and said find the equation for the ellipse. And if we look there, that point in the center is negative 1, 1. And so let's see what else we've got. So on the graph, you can kind of count. You can see that from the center to this vertex, it's 1, 2. Both ways, and on the minor axis it is 1. So A is 2, B is 1. That's going to give you 4 and 1 on the bottom. It'll be x minus a negative 1, so that'll be x plus 1 squared over 4 plus y minus 1 squared over 1, and we don't have to put the 1 in our final answer. So you're really just using the picture to do that. Number 12 is the same way. The center is at 1, 0, and it looks like, what do we have? So in this, from the center, which is at 1, 0, and you go up, that looks like that's at 5 and at negative 5. So we've got an A value of 5. This way we've got 1 unit, so B is 1. And so the A is going to go under the y. So y squared over a squared, which would be 25, and x minus 1 squared over 1. So we would have that. All right, number 13, I believe, is our last one. All right, find the center, foci, and vertices of the ellipse and graph the equation. All right, so we can see the bigger number here is 49, so A is 7. B is the square root of 16, so B is 4. Then we can come down and come up with our C value, and we have square root of plus or minus square root of 33. We can't really clean that up. All right, so the vertices are, and we know we're going along the y-axis, so it's H, K plus A, and K minus A. So fill in what you know. You've got 4. H and K are here. 4, negative 6. We got those from the top of the equation. So 4 and then k is -6 plus a, and our a value is 7. So that becomes 1. So we have 4 comma 1. 4, -6 minus 7, we have 4, -13. So those go this way. And it does say the vertex above the center, which is going to be a y value that's positive. Below the center, it's going to be a y value that's negative. The foci, we're going to just plug into the formulas. H and then k plus c. So 4, -6 plus the square root of 3, and 4, comma, -6 minus the square root of 33. And those would go there. And that one's going to be below center. And then, which graph shows the ellipse? They all kind of look a little bit alike, but the center is at 4, -6. So we are here. And let's see, we should be over this way on those vertices. It should be 4 either way, and that, I think you can tell that's 4 because 16, square root of 16 is 4. So 4 that way and 4 that way from that point. So I think you should be able to do that. That should get you through the ellipse.